this word for word, you can summarize, because there are a lot of words here. It's also a little hard to see, so I'm going to read them and then I'm going to summarize it, write what you feel is necessary. Definition of your intercepts. So an x-intercept graphically is the point or points where the graph crosses or touches or intersects the x-axis. Algebraically is the point or points at which y or f of x equals 0. So graphically it's where it crosses the x-axis. Algebraically is where y is 0. Y-intercept is the opposite of that. Graphically, the point or points where the graph crosses, touches, or intersects the y-axis. Algebraically, the point or points at which x equals 0. So graphically, where it crosses the y-axis. Algebraically, where x is 0. When we write our intercepts, they should be written as an ordered pair, x, y, in parentheses. X comma y in parentheses, there we go. And then in this last part, you really just need the words, you don't need the parts in parentheses. So x-intercepts are also called roots, solutions, and zeros. And then I'll read off the reasons for those. So roots, usually you hear with quadratic functions, which we are not doing right now, we're doing linear functions. Solutions, because it makes the equation true, which we talked about when we were solving. And zeros, because it makes the equation equal to 0. Bless you. When you have finished, go ahead and put your pencil down so I know who all I am still waiting on. If you need me to go back to this afterwards, I can do that. Okay. So here we just have to find the x and y intercepts from the graph. So wherever it crosses the x or y axis. So let's start at number 1. Where does this cross the x-intercept? And if it helps outline your x and y axis, here, I'll do that up here as well. Just so it's a little bit thicker or you don't confuse that. So where does that line cross the x-axis?
At 2.
At positive 2. So we would write that as 2, 0. Where does this line cross the y-axis?
-3.
Negative 3. So we would write that as 0, -3. So for this one, you just need to be able to recognize where does this cross the x or y axis. Let's try another one. Number 2, this one has 2 x-intercepts. Where is one of them?
-2.
At -2?
And positive 1.
Positive 2. So we can write that as 2, 0 and at -4. -4, 0. Where is your y-intercept?
2. No, like 1.5 something.
Where does it cross the y-axis?
Wait, is that number 2?
Should be at positive 8.
It's not 2.
Right there. So 0, 8.
Your graph is different than ours.
Yeah.
For the x-axis, ours is -2, not -1.
You're right. I keep forgetting that I changed that graph. Okay. So yes, on your graph, your x-intercepts are 1, -2, and your y-intercept is short 1.5. So write those down for yours, ignore mine.
So what's with the y-axis?
So you can make up a decimal 0, 1.5, 1.5 of course. So sometimes your x and y intercepts will be decimals. Actually, let me see. If the rest is also the same. I just don't have those two. Everything else is different. That's fine. What I was saying was sometimes your x and y intercepts will be decimals, and that's okay. It just depends on where it falls. Any others on this page we want to see, go over, have questions about?
Number 6.
So number 6, give me one x-intercept.
Yeah.
-5, 0 is 1. Where's another? 0, 0 is another. Are there any others?
3, 0.
3, 0 is another. So it depends on the function. Some of them can have multiple, some just have one. What about your y-intercept?
0, 0.
0, 0. Sometimes they can be the same. Really, if they are 0, 0, and that's it. Okay. Any others we want to see, do go over and have questions about? Go on to the next page. So we're going to do some of the 1 through 6. And then if we have time, go on to the calculator portion. But then there's some other algebraic ones we have to do, which we'll probably do on Thursday. So we're going to start with this first one. Right. So if we are finding x-intercepts, 1, we have to recognize that this f of x is the same thing as y equals. So if you want to change that to y equals, you can. You don't have to, but you can.
So fx is y.
Basically. F of x is function, y is your equation, but they're really the same thing. So to find an x-intercept, our y value has to be 0. So we're going to take the y, and instead of y, put 0 in for it.
Wait,
And
so
now-
why did you put 0?
Because every time we have an x-intercept, y is 0.
Oh.
Now we can solve for x. How would we do that?
Adding.
And divide both sides by 2. Now, we still have to write this as an ordered pair. So that would be 2, 0 since we're looking for an x-intercept, or we put 0 in for y, either or. Reason. Questions on how we found the x-intercept before we find the y-intercept?
Keep it on my screen for a minute.
Yes. I'm just going to write this right next to it. So for x-intercept, we would put 0 in for y. For y-intercept, we would put 0 in for
X.
X. It's the opposite. So it's going to be y equals 4 times 0 minus 8. So that your y value is your y-intercepts are going to be a lot easier to find in this format. Think back to when we were doing slope-intercept. Right now, these are basically in slope-intercept form. So this is going to be your y-intercept. You don't really have to solve for it when it's in this format. So if you notice that it's in this format, you could just say, this is my y-intercept, so my y-intercept ordered pair would just be 0, negative. You don't have to do the work for that one, but for the x you do. Questions on how we found the x or y-intercept for that one? Let's try another one. I'm going to skip some and do number 4, and then we'll go back into the you want to do. So let's start with the y-intercept. What would the y-intercept of this one be?
-6.
-6. And I would write that as
0 /
-6. For the x-intercept though, so I'm going to do this one without rewriting, but if it helps you to rewrite, go ahead and do that. I know that if I'm solving for x, my y value has to be 0, so I'm just going to change this entire thing, get rid of it, and put 0. And now solve for x. So we could add 6 to both sides. And then how to get rid of 2/3?
And
Multiply it, flip it by the reciprocal is what that's called.
where do you see?
So
Oh,
it is 9. That would be 18 over 2. So that ordered pair would be 9, 0. Right. Notice that after we get x equals or y equals, I'm putting x and then whatever the ordered pair is. Let's say you put your work over here, but then you put your answer over here. You have to label which one is your x-intercept, which one is your y-intercept. That's why I keep doing that.
is it fine if we like use 2 different colors and put it on the pie on the top of the paper? This color equals this.
That would also work, yeah. Right. Are there any others in 1 through 6 that we want to see, do, go over, have questions about? Okay. So, if we have questions later, we'll come back to those. So now on the bottom, I'm going to show you how to put these in the calculator, how to find the intercept on the calculator, and on Desmos. Calculator first, because that takes the most steps. So we're going to do number 1 at the bottom in the calculator. The steps are on the side if you use me. So we're going to go into y equals at the top. If there's anything in there cleared out, actually let's reset our calculators. I forgot that some class was doing something else. The second plus 7, 1, 2. Reset it. And then after you reset it, go back into y equals at the top. And we're going to type in x squared minus 16. There's already a y there, so I don't need to put in the f of x. X squared, make sure you put the variable before you hit squared, minus 16. And then you're going to graph it, hit the graph button at the top. So we've graphed, some function, and we want to find the x and y intercepts. So,
Wait, it didn't work for me.
there are different steps for that. That's because you didn't put in the variable.
How do you set a calculator?
You don't need to reset it, just delete it. So we want to go into calculate, which is above trace. So second trace. This is where you're going to find your x and y intercept. 0, remember, is another name for x-intercept. So if we go into 0, that's going to help us find our x-intercepts. So number 2. But then it's going to ask you for a left bound. You can only do this one at a time on the calculator. So let's say I can see that this is at -4, but let's say I want to make sure it's at -4. I want some number to the left of this. So someone give me a number left of this. -5, -6, any of those work. So I'm just going to type in that number, -5, and hit enter. Yours may just be a cursor, but mine is a line. Some line appears to show me I'm not looking past that point. Then it's going to ask for a right bound. There has to be something to the right of this that doesn't go past my other one. There's something in here. Someone give me a number.
1.
1 works, or 0, -1, any of those. I'm going to type in 1, I'm going to hit enter. So now I have barriers. It's going to look in between those 2 points to find my x-intercept. Now, it says guess, but that would be if you want to like manipulate it and move it, which you don't. So just hit enter again, and it's going to tell you what that x-intercept is. -40, which we knew we could see it, but we just want to make sure. I'm going to write that down. So -4, 0. I'm going to do the same thing for the other one just to make sure. It looks like it's at +4, but I just want to make sure. We're going to do that process again. Second trace, 0. Now I need a left bound that's left of this, so some number in here. 2, 0, negative, and any of those numbers work. So I'm going to type in 0. You can't really see it, but there's a line on top of the y-axis. Now I need a right bound, some number to the right of this. 5, sure. I'm going to type in 5, hit enter, and enter once more. And I get my x-intercept, 4, 0. So that's how you find your x-intercept on a calculator. To find your y-intercept, go back to second trace. And we're going to go into value now instead of 0. So number 1. And it's wanting you to put an x value in. So when we're looking for y-intercept, our x value is what?
0.
0. So that's what we're going to put in. And hit enter. And it should tell you what that y value is. So 0, -16 would be our y-intercept. And for something like this, these, you wouldn't have to show work because you don't know how to find these algebraically yet. But linear ones that don't have exponents, you could solve those. Okay. Questions on how you find x and y intercepts in the calculator? Okay. Now we're going to do one in desmos. So pick 1, 2 through 10. Which one do we want to do? Numbers 2 through 10?
10.
Sure. So go into desmos. And you're going to type in 10 except for the f of x. So everything after the equal sign. You can use this for your exponent, the a to the b. But then you have to come to the right, go to the right to get out of it. now it just looks like a bunch of lines, but if you zoom out, you can see that it's doing weird things. If you click on the graph, it's going to highlight all your x and y intercepts. So again, this is for things with exponents because you don't know how to solve those yet. Not for linear ones, but you could use this to double check yourself when practicing at home and things like that. Questions on how we find intercepts on Desmos? Much easier on Desmos than in the calculator. All right. I want you to go through the rest of 2 through 9 and find your x and y intercepts. I'll write these down for number 10.